Hello NG India. So, before we dive in, do we have anyone in the audience who have played around with machine learning before? Hands up. All right, it's a couple. Nice, nice. How about Transformers.js? Have anyone tried it out before? Very nice. And has anyone used it in their Angular apps? All right, cool. So last year, I spoke at NG India for the first time, and I shared how Angular can be a solid platform for client-side machine learning. We looked at using deferrable views to lazy load heavy models, structuring machine learning logic, and offloading compute with web workers while keeping the UI responsive and the architecture clean. And I began my talk by referencing a tweet from Julien Chamond, the co-founder and CTO of Hugging Face. And in it, he said, "My prediction for 2024, yes, I have only one, local machine learning is gonna be huge." So, has client-side machine learning taken the world by storm? Well, it's hard to say, but it's definitely a trend that has been growing this last year. And it's something that has become more mainstream for sure. And Julien and Hugging Face is making big moves in the client-side machine learning space through the Transformers.js library. And today, I'm really excited to show you how we can bring that power into our Angular apps. So by the end of this talk, you're gonna know why client-side machine learning is such an exciting tool to have in your dev toolkit, how the Transformers.js API works, and how it gives you easy access to local machine learning models. And most importantly, how can we integrate Transformers.js to your Angular apps to build smart, privacy-friendly, and performant web apps. Quickly about me, I'm Markus. I'm a software engineer. I live in Stockholm, Sweden, and I'm a co-organizer of the Angular community meetup. So let's real quick do a 30-second summary on machine learning. So machine learning is a method where computers learn patterns from data and make decisions or predictions without being explicitly programmed. So instead of writing rules to classify, let's say, images of cats and dogs, we feed a large data set containing labeled images of dogs and cats into a machine learning algorithm. The algorithm then learns to recognize patterns in the pixel data that distinguish dogs and cats from one another. And over time, it builds an internal model of what a dog or cat looks like, enabling it to classify new unseen images of dogs and cats. So, what's the deal then with client-side machine learning, and why and when should we consider using it? So first and foremost, a significant benefit of client-side machine learning is that it brings a great user experience without any network delay. So when using server-side machine learning, there is a round-trip cost that has to be paid in terms of network latency, since the machine learning inference is done remotely. But with client-side machine learning, it's all done on device, enabling near instantaneous real-time classification. And a huge enabler for machine learning has been the GPU, the graphics processing unit. It's a component traditionally used to render graphics in video games, but just like games, machine learning relies on performing large amounts of relatively simple calculations in parallel. And thanks to Web GPU, a new web graphics API, we can now utilize our client's GPU through the web browser, allowing for fast computations on device. And as of April 2025, Web GPU is fully supported in Chrome, Edge, and Opera, and Safari and Firefox offers experimental support. So with no network delay and access to my laptop's GPU, let's check out what fast on-device machine learning can look like. Here we're going to see a quick demo of a hand pose detection model running locally in the browser. So without any noticeable delay, we are flying at roughly 80 frames per second, which is quite nice, right? Another key advantage of client-side machine learning is that it's inherently private, and it can actually even function entirely offline. But what does it actually mean when we say private, when we talk about machine learning on your device? Well, it basically means that rather than sending images or text or other pieces of information to a remote server in the cloud, we pull down the entire machine learning model to our device. And this can, of course, take some time to download, and as you can see, it can take a bit of space as well. But once the model has been downloaded, we can use it completely freely offline. And all processing happens locally on your laptop or phone. No data leaves the device. No network calls are being made. Just fast, private inference locally. And finally, another great benefit of using client-side machine learning is that it's cost-effective. So background blur in video calls is a great example of where client-side machine learning really proves its value. So a single 30-minute call at 30 frames per second generates over 54,000 frames per user. So that, now imagine 1,000 users in daily meetings. That's 54 million frames that needs to be processed each day. Scale that to 10,000 users or even 1 million users, and you're looking at billions of images to segment every day. So running that kind of workload on the server would be incredibly resource intensive, making it quite a tough feature to roll out widely. But by performing it locally, it becomes far more cost effective to deliver at scale. So the benefits of client-side machine learning are clear. It's fast, private, and scalable. Sounds great, right? So let's dive into the fun part. How can we actually use powerful models in the browser? So the star of the show today is Transformers.js. And it's a library started in the beginning of 2023 by user Senova. And it gives us access to pre-trained machine learning models right in JavaScript. So since they're already trained, we skip the massive compute cost and time of training them from scratch. And the best part, you're tapping into state-of-the-art models developed by industry leaders like Google, OpenAI, Microsoft, Meta, along with contributors from some of the brightest minds in the machine learning community. And if you use the Python library, you'll feel right at home. Senova, the creator of Transformers.js, and the open source community have done a great job making sure that the Transformers.js API is closely aligned with the Python version. And finally, Transformers.js supports over 100 different architectures covering a wide range of real-world cases, and we will dive into those specific tasks in a moment. So, to set up Transformers.js is as easy as doing an npm install at Hugging Face/Transformers. And one of the best parts of Transformers.js is the pipeline function. It gives you a simple, high-level way to run machine learning models without worrying about all the moving parts under the hood. So when you create the pipeline, it takes care of 3 major things for you automatically. So first, it loads a pre-trained model. It pre-processes the input, like converting text into tensors. And it post-processes the output, like turning logits into readable labels or decoded text. So instead of writing a bunch of boilerplate code, you can just call a single function and get useful results, which is really developer-friendly. So here we are witnessing our first tiny Transformers.js example. So let's zoom onto the first argument here. We pass the pipeline function. This is the task, and it tells the library what we want the model to do, essentially. So for example, passing translation gives us a translator. So we give the translator the text, my name is Markus, and it returns the French version, mon nom est Markus. Yeah, close enough. Hope nobody speaks French here. So, tasks are at the core of Transformers.js API. Whether you want to summarize text, translate between different languages, or detect objects in an image, transcribe speech, you name it. It just works with the same consistent interface. Just change the task name and you're instantly working in a different domain. So now you might be wondering, why don't we just use one big model that can kind of do everything, right? That's the trend that we've been seeing these last years. Well, the reality is that in the browser, we are working with constraints. There's a limit to how large of a model we can reasonably load and run. And large general purpose models, they are powerful, don't get me wrong, but they often come with massive file sizes and high compute demands. And that makes them sort of impractical for front-end apps. But in many cases, you don't really need a model that can kind of do it all. You just need one that is really good at one thing. And with Transformers.js, switching between those focused, lightweight models is as simple as changing an argument, essentially, which is awesome. And we saw earlier that our default translator could handle basic French translations, but when translating to Hindi, the results aren't really top-notch. And that's because by default, the pipeline function chooses a generic model under the hood, which is good for quick demos, but not always the best for specific use cases. But here's the good news. The pipeline function accepts a second argument, a model ID. And this is really great. So by passing in a model ID, in this case, we pass in Senova/NLLB 200 distilled 600M. It's a bit of a mouthful, but once we've done so, we are all of a sudden capable of more powerful translations. So this loads a multilingual translation model distilled from Meta's No Language Left Behind project, which supports over 200 languages. So instead of prompting what translation we want, we include an object with a source language equal to English and a target language equal to Hindi. After passing the text, my name is Markus, we get the output, which can be seen at the bottom of the screen there. Mera naam Markus hai. Now you might wonder, where do these model IDs come from? Well, let me show you. Over at huggingface.co, there's a huge public model hub, kind of like GitHub, but for machine learning models. So you can search for tasks like translation, filter by library support, and explore over 1 million different models. So let's do a quick tour of the site so you can see how easy it is to find a model to use in your own pipeline. So if we click the models link at the top bar, we can see a long list of machine learning models. To the left, we see a bunch of filters. So first, let's filter tasks by translation. Secondly, let's go to the Libraries tab, and there we can see Transformers.js. And now we can see 114 different models for translation available at our fingertips. And at the top, we recognize the model that we have been referring to in our small translation app. So if we click it and check out the details, we can see documentation on how to use the model, alongside with corresponding files of the model, community requests, and much more. And we recognize the name at the top of the model ID that we referenced in the pipeline function. So when we reference this model, what happens is that Hugging Face downloads the files in this repository to our browser, and we can immediately start using it at our comfort. So after having finally, briefly touched on the API of Transformers.js, let's do something more than just a toy example. So this screen dub kind of gave me some inspiration. This was me from the time that I was working on my thesis in school. And I kept getting ideas while I was on the road. And I don't know about you, but when I get a good idea, I find it just easier to record myself, mostly because I'm such a poor typer. So I'm kind of screwing up the flow when I'm trying to type and correct my spelling mistakes. But consuming audio can be quite inconvenient at times. If someone sends you a long recording, for example, as a reply, you can't skim it, you can't speed read it, you kind of just have to sit there and listen, right? So audio recordings may be really convenient for the sender, but they can create some friction for the recipient at times. So let's make history. Let's build another notes-taking app. I know, groundbreaking. Save the standing ovations for later. So let's build it with Transformers.js using a speech-to-text model to create rich notes containing both the recording but also the transcription. So let's check out the demo today. Quickly, the project structure. We start with our app component, which contains a simple header with an H1 tag and a paragraph. Furthermore, we have a presentational note card component to display our notes. Right now we can listen to the playback audio, but there is no transcribing in place yet. And if we zoom into the audio recorder component, template-wise, just a start and stop button, nothing fancy here. And once the recording is complete, we emit the playback URL, so we can listen to the recording, as well as the processed audio that we're gonna use for our model. Besides these two components, we have a loading bar component and a spinner component. This is simply just presentational stuff, so we won't dig too much into that for now. There's also a web worker folder. To remind us though, a web worker lets us run JavaScript in a separate thread from the main UI. And this is especially useful for client-side machine learning apps because it keeps the heavy model inference from freezing the app. So the app stays smooth and responsive. Here we set up a very basic web worker. When the web worker receives a message of type speech to text, we will process that accordingly. For now though, we just log the message, but we're gonna update this very soon. And then we have a web worker service, which is just, in this case, an Angular service that wraps the web worker. And in the service, we set up the web worker, meaning that we instantiate it, and we set up a handler for the onMessage event. So in this case, we will call the registered callback functions. And you can see there is a simple method, which we will send messages to the web worker, and also a very simple method, which will register the callback function when the web worker responds with a message. So we can handle that. And as you can see, a couple of types here. And they are defined in this index.ts file. The types here are simply added to type the communication with the web worker. And last but not least, we have our transcriber service, which is the service that creates the rich notes and most of the state management in our app. Right now, every time someone calls the transcribe audio method, you can see that we simply return the playback URL right away, and with a static text transcribing. But yes, let's change that. So let's do some demo. I'm gonna see if I can. Nice, okay, let's just see if I quickly try to, hello, how are we today? We can see a card, it says just transcribing static text, and let's see if we can hear the audio. Hello, how are we today? Yeah, it sounds good, it sounds good. Nice, so let's see. I did not think this one through because I would like to code, but at the same time I would like you to see the code. Let's see how we can do this. Can we do this effectively? This will be interesting. I actually have, let's see. I actually have a recording. I did not try this one out, so I have a recording of me doing the live coding. So let's check that out so I stay on time. Right, there is no internet at this point. Okay, I will do some live coding quickly, and let's see how this turns out. I'm sure it's gonna be great. Let's see. This will be a first. Okay, let's see. Nice, we are at the live demo one. Great, so let's start out. So what I first want to do here is that I actually want to create a file. Let's create it through the command line, as that will be easier. I'm going to call a transcriber pipeline file. Pipeline. Very nice. Transcriber pipeline. Great, and here we're going to create the, oh, very nice. I see it down here. I'm an idiot. I see a small screen here. That might be easier. Let's see. We're going to create a transcriber service with a funny looking name. And I have installed Hugging Face already, the Transformers.js library. So what we can do now is we're going to import the type of the pipeline, automatic speech recognition pipeline. And let's make this class return the instance. So here, very nice, almost. We have a promise of an automatic speech recognition pipeline. And let's create a method that simply returns this one, get instance. Let's see if I can maybe zoom in to make it a little bit easier. I hope that is better for the people in the back. So this will simply return the instance. And if this has not been instantiated, we are going to make sure to instantiate this. And we have seen this a couple of times now already. We are, of course, going to use the pipeline function. And first, we're going to pass in the task. So the task will be automatic speech recognition. And the second one is going to be the model ID. I happen to know this one already, so let's save ourselves some time. And I'll just add Cenova/whisper base. And then we're also going to add an object. And in this object, I'm actually going to add a progress callback. And if we read here quickly, what is a progress callback? Let's see, it's a little bit small, but it says, this function will be called during model construction to provide the user with progress updates. So this is kind of nice to have when we want to essentially update perhaps a loading bar in the UI to make sure that the user understands that something is happening in the background. That is, we are downloading a machine learning model. It will take a minute. Just wait a second. So what we're going to do is we're going to make sure that the person who instantiates this also pass in a function. It's going to be a function with an argument, progress info. Let's see. And it returns a void. Great. OK, we managed to create the transcriber. I call this one a transcriber service. That was probably not intended. It's a transcriber pipeline. That's what we want to call it. Very nice. So let's go to our transcriber service. And now let's create a loading bar. Loading bar is going to be a signal. Sorry, let's see, with a loading bar props type. And let's instantiate this for now. With a label saying, let's do loading. Progress will be 0. Nice. Let's go to the app component. And let's go to the template. I'm going to go down here to the template. Let's add a section. Let's add the loading bar. And let's pass in, let's see, the loading bar prop. And it's going to come from the transcriber service. And we're going to call the signal that we expose. So nice. OK, let's go to the browser. And I'm going to refresh. Sorry, let's make sure that we serve the application. I'm going to refresh the page. And we see a loading bar. Very nice. Maybe let's hide it if the value is 0. So let's see. So if loading bar, transcriber service, dot loading bar, if the progress value is bigger than 0, then we show it, right? But otherwise, let's not. Very cool. OK, we have the progress bar in place. So now let's actually go to the web worker, and let's instantiate this model that we just created through the transcriber pipeline, and then register a callback function. So I'm going to do const, let's see, transcriber, and we're going to use the transcriber pipeline. We're going to get an instance, and I'm going to register a progress callback. So let's define this callback here. So this is the function that we will pass in when the model is being created. So in the case of, if we receive a message of status, progress, then we want to communicate that to the main thread so we can update the loading bar. So here I'm going to do const, let's see, progress response. It's going to be a type of worker response. And what we are going to see here is we're going to see a response type of speech to text. So the message will be able to be categorized. We will pass down a status that will be progress. So our service will know what this message concerns. It's a progress update. The file name we get from this progress info message, as well as the progress. That is, how much have we downloaded, how many percent. Progress info dot progress. Nice. So here we got the progress response. Let's post that message to the web worker. Through the web worker, nice. And let's also take care of the case. Well, let's do that later. Nice. Let's go to the transcriber service now, and let's make sure that we use this. Let's see. Here we go. Let's see that we use this web worker correctly. So I'm going to instantiate the worker service. Worker service. Almost. Nice. And then I'm going to first register this callback function. So the callback function will take a look at the response. And first of all, if the web worker sends us a message that is not of type speech to text, then we actually just want to ignore it. Then it's not of concern to this service. We don't care. However, within this context, we know that the message will be of type speech to text. So let's switch over the status. And if it's concerned about the progress, well, then we are interested, because then this is a way for us to update this loading bar that we have instantiated. So the label, we'll take the label from, let's see, response.filename, and then the progress will come again from the response. Very nice. So let's see. Let's go to the UI, and I'll click Start Recording. I'm just going to make sure that I actually post a message, because if we don't post a message, the service won't actually get instantiated. So message type is going to be of type speech to text, audio, playback URL. Nice. So now, when we transcribe the audio, when we click here on the stop, and then we click on the stop, this method will get called. We're going to send a message to the web worker. The web worker will, for now, just instantiate this transcriber, but it will register the callback function. So if I click stop, we see this little loading bar, and we also see the file names that we are downloading. Nice, awesome. So let's go to this app worker again. And let's quickly do something fun here with the transcriber, because we instantiate the transcriber because we want to use it, right? So now we have handled the case where we show a loading bar. Let's also actually do something. So I'm going to use the transcriber, and it's actually an asynchronous function. And I'm going to pass in the audio. This is the processed audio that comes from the recording. And once we have the output, I'm going to create a complete response. And yes, response type, speech to text, you know it by now. The status is going to be complete because we're sending a message that is concerning regarding this complete action. Since it's a complete action, let's see. We are going to pass in the playback URL. This is actually just something we just pass right through. And then the text, I'll just use the autocompleter to make a little bit shorter lines. Let's take the output here. So let's see, output. And we actually have to cast it because it can be a single output, a single text, or an array. But this is just a single text in this case. So now we have the complete response. We post this message to the main thread. So let's go back and take care of this message here in our transcriber service. Maybe this is a little bit zoomed in. I'll just zoom out a little bit now. So I'm actually going to take this update of the notes. Here we created a note with a static text, but let's move this to the case here in this switch statement where we are actually listening to this complete action. So when we're listening to this complete action, here we're actually going to have, let's see, response, playback URL. Here we're actually going to know the transcription, right? Because we pass it from the transcription done by the pipeline. Nice. And yeah, I think that's it. Let's go to... The time's over? Okay. Let's go and quickly just show the recording. Hello, how are you? Very nice. The recording. Hello, how are you? And as my time is over, I'm not going to drag this out. Let's go to the pipeline. I'll simply show here that we can also add web GPU as a device. Let's serve the app. Hello, how are you? And now when the model is loaded, let's do a long one. Today we are building intelligent web apps with Transformers.js and Angular. Pretty fast. All right, I'll cut this short. So to summarize, we can build fast and responsive web apps with Angular and Transformers.js. It's private and offline, and cost-effective at scale. So where can you go next? Well, train or fine-tune your own models. The possibilities are endless here, really. Join the Hugging Face community. It's a fantastic community where you can learn tons from great minds and contribute yourself. And this tech is made so you can get creative and build amazing products and web apps. So go out there and get creative. Thank you very much for listening. It was a great time to be here. Thank you.